Good day, folks. Welcome to Pride's Mind Academy, where we bring brilliance to every lesson. In today's video, I want us to look at a acid-base type of question, okay? So it says NH3 reacts with HCl to form salt, okay? Remember, HCl, it is a base. So NH3, it is a base, and HCl, it is an acid. Remember, the reaction of an acid and a base results in what? In a salt and water. Okay, but in this case, there was no water. So they say identify the base in the reaction. So we know HCl, it is a common acid. So now the base is going to be NH3. Give a reason for your answer. Now, what you can say is that it does what? It, what's the definition of Arrhenius? Remember, a base, according to Arrhenius, it is a substance that dissociates in water to form hydroxide ions, okay? Or rather, a substance that forms hydroxide ions in water, okay? So you're gonna say, you can say forms OH minus where? In water, okay? Yes. Another reason that you can say it is a it is a proton acceptor, or it is a proton acceptor, okay? Remember, when it accepts a proton, it's going to be NH4 plus. So let's move on. Write down the name of the salt formed. So remember, NH4 plus, this is hydronium, okay? This is Cl. So now hydronium plus chlorine ions is going to form us hydronium chloride. Hydronium chloride, okay? Yes. If I've mentioned it correct. Now, they say NH4 can undergo hydrolysis. Remember, the salt that can undergo hydrolysis is from a strong something and a weak something. Remember, acid, it is a strong acid. HCl, sorry, it is a strong acid. And ammonia, it is a weak base. So they say define hydrolysis. Hydrolysis, it is the reaction of salt with water. Straightforward. Now they say write down a balanced equation for hydrolysis of NH4, okay? Indicate whether the solution is acidic, alkaline, or neutral. So I want us to do it here. Say we have NH4. First step, okay? The first steps. The first one, you need to ionize or dissociate it, okay? Okay, it is a salt. I can do it. Break it. Okay, let me say stock a simple English. Break it again. Then number two, some okay. Let me say ion from weak something will react with water. So the first thing first, I repeat, you need to break it again. You need to break it. Break NH4 Cl into NH4 plus Cl minus. Step number one complete. Step number two, ion from weak something will react with water. What do I mean ion from weak something? Remember, these are now ions, okay? So now where does NH4 comes from? NH4 comes from NH3, okay? Then Cl minus comes from HCl. How do I know that NH4 comes from from NH3? Because remember, NH3, it is a base, and a base accepts a proton. When it accepts a proton, it forms this one. How do I know this one? It comes from an acid. Remember, an acid it is a proton donor. When HCl donates a proton, which is H plus, it is left with this one. So the one that comes from a weak something, so this is weak. Remember, you said this is a weak base, this is a strong. The one that comes from a weak something is the one that will react with water. So I'm gonna take my what? NH4 plus react it with water. It's gonna form what? Can you see now? This NH4 here, this NH4 here has the capability or the ability to donate a proton because it is already in excess. So what does that form me? It forms H3O plus what? NH3. So now this is your balanced equation. This is your balanced chemical equation. Now we need to indicate whether the solution will be acidic, alkaline, or neutral. Now remember, when it forms me, when I form hydronium ions, it means now my solution it is acidic. Why? Due to the formation of hydronium ions. Okay? Yes. If I formed OH minus, it means my solution is basic. And how did I know that my solution is going to be acidic? Because now, or my salt is acidic. Because now this is a weak base plus a strong acid. Remember, a strong plus a weak, it is always the strong that wins. So a strong acid will overcome the weak base. So now our solution will be acidic. So this is how we get to know if something it is alkaline. Uh, Alkaline refers to basic and all of those things. Okay, yes. Let's move on to titration type of equation. Okay, let me erase this quickly. So the diagram below shows the titration of 200 and also the diagram below shows the titration of 25 milliliter of sulfuric acid of unknown concentration of 0.2 sodium hydroxide. Okay, so now remember what is titration. Titration is a process of it is the process whereby an unknown solution is determined using what? A standard solution. So now we are told that the solution below, so the diagram below shows the titration of 25 milliliter cubed of sulfuric acid. Here is that 25 milliliter cubed of sulfuric acid. Okay, remember that milliliter cubed is equivalent to centimeter cubed and liter is equivalent to decimeter cubed of unknown concentration. So this one is of unknown concentration. Okay, so this one needs to be of known concentration. Hence now they are saying it is a standard solution. Okay, with 0.2. So it means now I have concentration of, this is the base, 0.2 mole per decimeter cubed. Okay, now do I know the volume of the base? They did not tell me. Now I only know the volume of the base, which is the same as let me say, so this is the acid, volume of the acid 25 milliliter, which is the same as 25 centimeter cubed, which is the same as 0.025 decimeter cubed. Okay, now do I know the concentration of the what? Of the acid? No, I do not know. They told me of unknown. So now they say the balanced equation here for the reaction is H2SO4 plus 2 sodium hydroxide forming now sodium sulfate plus 2 moles of water. Identify the apparatus A. Apparator A, it is now burette. Burette. Remember, this is a burette. This is conical flask or Erlenmeyer flask. This is a retort stand. Retort stand. This is a pipette. Okay, yes. They say now promothermal blue was used as the indicator in the titration above. Write down the color change. Now, I need you to remember this. Mary, baby, pack P. Mary, baby, baby, pack P. So now they are telling me they used what? Promothermal blue. Promothermal blue. So the promothermal blue was used in the indicator in the titration above. Write down the color change observed. So now, remember, they poured. Before you do titration, you need an indicator. Oh, sorry, this is not a pipette. You need an indicator to be poured. So now the indicator is first poured on the what? On the conical flask, which has an what? An acid. And now, according to my analogies, that my promothermal blue, my indicator, which is promothermal blue, in acid is yellow. So promothermal blue in acid, it is yellow. But in base, it is young, it is blue. So when now, as I add my sodium hydroxide, I'm adding my base again. So the color change will change to what? When I add my base, will be what? Will be blue. So it means my color change will move from yellow to blue. So from yellow to blue. So yeah, boom. That's it. That's it for this question. I hope you enjoyed it. Okay. Join me on more videos that include now calculations. Okay. Yes. Thank you very much, folks.